Hello everyone, welcome to Data Science and Algorithms. My name is Sixus Dakra. So in this video, we are going to take a brief overview of Google Colab, which is our main development environment. We also have like a short introduction to Python. So all you need to work with on Google Colab is just a browser and some internet connection. So bring up a new browser window and type in Google Colab on your search bar. And then the first item that comes up leads you like to the Google Colab website. So if you click on that, it loads up the homepage for you. And in here, there are some starter examples that you can take a look at. If you've been working with Google Colab, there are also some recents that will show up here. You can also import some files from Google Drive or GitHub, or if you have those files in your local machine, you can upload them. We are going to start with a new notebook. So if you come to the bottom here, you have new notebook and cancel. So we are going to start with a new notebook. Just click on that. It takes a few seconds and then it loads up the Colab environment for you. At the top here is the title of our notebook. So I'll change it to Python overview. And then the interface is very simple and intuitive. If we check to your right, you have a connect button here. And this is where you create an instance of Python to work with. So if I just click on it to allocate me some resources, that is my RAM space and then my disk space. And then it's connected. If you hover over it, you see that you have your compute engine being Google backend, and you're running on Python 3. You also have a RAM size of 12.72 gig, and then a disk space of about 225. That is a lot for the purposes of this course. You can change the runtime type if you wish to. If you just go to run type here and click on change runtime type, here you can choose whether you want to use a GPU or a TPU. And you can even increase your RAM size to like say a high RAM in case you're running some models that require like high RAM. But for the purposes of this course, we're gonna stick with the defaults because 12 gig of RAM and then about 200 gigabytes of disk space is enough for our work. So Google Colab basically allows us to add text and code chunks as well. So for example, if I want to just write ordinary text, I can just click on this plus text. It brings out like a text editor for me and I can type anything that I want. If I want to add code, I can bring up a code chunk and then I can type anything that I want that is related to Python code and then to execute. So once I want to execute this, I just click on this play button here and then executes that. Okay. So that is just a brief overview of the interface of Google Colab. If you check to your left, you also have table of contents. That is, if you are writing and you're using text, sometimes it shows up here. Here you can upload files. There are already some sample data that you can look at, but we won't be using this for some purposes that I'll explain later on once you go to exploratory data analysis. Okay, so let's look at what is Python, right? On GitHub in 2019, Python is one of the most popular languages. I think third most used, mostly for machine learning, data analysis, and web programming tasks. It comes with various implementations, one of them being CPython, which is commonly used for web development, application development, and scripting. It also comes with an implementation called Anaconda, which is specialized in tasks like scientific programming, data science, and machine learning. It also has IronPython, which is an open source implementation of Python. This is built on the .NET runtime. There's also the implementation called Jupyter Notebooks. In fact, we are using like Jupyter Notebook right now. It's an interactive programming environment that supports a variety of programming languages, including Python. It's web-based. It's nice to emphasize that. So those are the four common implementations of Python. So right now, let's take a look at variables and basic data types in Python. As I mentioned earlier, this is not supposed to be a full-blown introduction to Python, but just a brief overview. So if you need to learn more, there are a host of resources online that you can consult to get you started on Python. So in next sense, variables holds data in memory, right? And what do I mean by that? If I want to store a value and use it somewhere down my computation line, then it might be nice to assign that value to a variable, right? So for example, I have a value of 20, then I need to probably add another value, 50. Then what I can do is, okay, let's say x is equals to 20, right? So what this means is that I'm assigning the value of 20 to x, and here my assignment operator is simply the equal sign, right? Then I can say, okay, let y be equals to x shift plus 50, right? So in this case, I'm assigning 50 plus x to y, right? It's not only numerals that I can assign to variables, I can assign strings to as well. So for example, I could say name is equals to your name. So here I'm using single quotes, but double quotes too could work as well. So these are that's how variables are created. So on the left is the variable name, on the right is the variable value, and then we use the equals to as the variable like operator sign. Okay. It's important to mention that variables are case sensitive, so name and then this are quite different. Right? If I type capital name and name, they are two different stuffs. And also, variable names cannot start with a number, and then no type declaration is necessary in Python. Like if you're coming from a different background, you might probably know that they always have something like int x. That is, we declare the variable type x as an integer. That is not necessary in Python because Python is dynamically what type. Okay. So that is it for variables and assigning values to variables. So how do I work with numbers? Right. So for example, if I assign x to be equals to 1, Python interprets this as an integer. Right. And then I can also assign x to be equals to 1.0. Python interprets this as a floating point. You can check the variable type just by saying print type of x. For example, let me change this one to y. Then let's run this, and then I can say print type x. See the type that it will print for me is class of int. Then I can do the same for, let me say, the y, and I have print type y. Then it gives me a class of float. So that shows that like x here is an integer and y here is a floating point number. All right. So we can also do the same for strings. So for example, if I assign my name to name here, I can do print type name, and then it should show me that like this here is a string. So the shortcut is str, which is short form for string. So another thing, probably for those of you who might not be familiar with Python, is commenting code, right? So what I've done here is a comment. So if I want to probably like add comments, are mostly basically used to guide people like that are reading your code. So if I say okay, assign age, so I can say age is equal to 20. Someone that's looking at my code will say, okay, this variable here represents age. So this is quite obvious from the variable names, but this is how you comment something. So I can comment this out, and then once I run it, nothing happens, right? But if I don't comment it out, I can print age here, and then I have my value. So commenting is used to either give information about what you are working on, or to leave out code that you don't want to run, basically. So that is just a very brief overview of comments, variable types, and assigning and using them. So let's look at how we can install and load packages in Google Colab. Throughout this course, we like pulling packages from various sources and using them to build our models, right? So to import a package, use the import keyword, and then you type the name of the package you want to import. So for example, if I want to import NumPy, which is a package we use over and over again in this course, I can just type as import NumPy, and then it imports this package for me. If I want to use this NumPy, all I have to do is say NumPy dot. I use the dot method to access I use the dot symbol to access methods in the NumPy class. So numpy.abs absolute, and then I can use that. But you realize that this NumPy here is quite tedious to type. I have to type like 5 characters. So what I can do is instead I can say import NumPy as np. Right. So if I want to now access methods in this NumPy class, instead of typing the entire NumPy, I can just type np here. So here I can just say np dot absolute. Right. So that's a very cool shortcut to know. And then aside importing packages, sometimes you might import a package and realize that it's not available on your Colab environment. Then you have to install it, right? So to do that, basically use the Python package manager. So you have notepip install. Let's say sklearn, right? So that's all you need to install a package. So notepip means that like we are not in an interactive Python environment. So we are letting the environment know that this is what we are doing, and then the install keyword, and then your package name, sklearn. So if I run this, it will try to install sklearn, but then I already have it installed, so it's saying that like requirement already satisfied, and I'm all good. But if I have a package that is not already installed, this is how you install packages on Google Colab. All right. So that out of the way, let's see how we can load data in Google Colab. So here you can upload files to Colab to use them, but once you close your session or once your session expires, Google automatically deletes those files. So it's not a good idea to store files here, because anytime you want to run your model, you have to upload them again. That is not efficient. So what I'll propose is that we will store our files on GitHub, and then we read them from GitHub directly and work with. So let's see how we can load data in Colab. To do that, I'll use the package pandas. So I'll say import pandas as pd, right? And to read data, mostly our data is going to be in CSV format, or it can be in TSV format or other format that we come across, and we know how to do that. So for now, the data we're going to use is the IMDb movie data that is stored on GitHub. So if you go to our GitHub page right here, you go to week 2, then you can look at IMDb movie data. And then what we want is the URL of this file, but don't copy this one right here, that will not work. Click on raw, and then copy this URL, right? So we will now say pandas.read underscore CSV, and then we paste the URL here. That's all we need to read the data in. So we run this here, and then probably we might want to assign this data to some variable. So I'll say, okay, IMDb data is equals to this, right? So that is all we need. And then sometimes too, because it's CSV, it's just nice to indicate to pandas that we are reading what CSV data. So I'll say separator is equals to comma. CSV means comma separated files, or the format is comma separated, and then I'll just add header being equals to 0 because I already have headers in my file. So this is all I need. Then if I run this, it reads the data directly from GitHub for me, and then I can take a snapshot view of the data by typing IMDb data.head, right? And then once I run this, this is what I'll get. You see, I have rank, title, genre, description, director. The column values here are my futures, and here I have my observations, right? So we can get the shape of this data. And how do we do that? So I can simply say n is my number of observations, m is the number of futures that I have, is equals to IMDb data.shape, right? I can do this, and then I can say print print number of observations, right, is n, And then we have number of futures. Futures is M right here. And then we can run this. If we run this, we should get that the number of observations 1000 and number of futures 12. So we have 1000 observations and 12 futures basically. And then we can look at the entire data set if we want by just typing IMDb data right here. If you do that, that is all our data set showed here. It won't show all like the rows because that will be a lot. So it just shows I think 0 to 4 and then it's cast off and then to the last end, right? But that is how you load data from Google Colab. And yeah, we are going to be using this technique throughout. That is reading files directly from online instead of storing them here, which gets deleted once you close our session. Okay, so that is it for a brief intro to Python and how to work with Google Colab in terms of loading data. And thank you guys, and I'll see you in the next video.